Hello viewers, my name is Damilari. In this class, we'll be looking at the chemical properties of alkanes, alkynes, and alkanols. In my previous video, I've talked about the introduction, the physical properties, the uses, and laboratory preparation of all these subtopics. But today we'll concentrate on the chemical properties. So we start with alkane. And how will you remember the chemical properties of alkane? You can start from the suffix "kane", just like a school using cane. Maybe a child was beaten and the parents of that child had to visit that school. So cane, school, visits. From the cane, once again, alkane. Then the school, S and C, representing substitution and combustion, meaning that the alkane can undergo substitution reaction. Why is it undergoing substitution? By the time you write out the formula for methane, for example, when you write CH4, it shows that all the spaces have been occupied because the bond around carbon must be 4. So it means all the spaces have been occupied, meaning that HHH has covered the whole of this. So it means if there is any other element coming to add to this alkane, one of them would rather be substituted for it. That means H will leave for that thing to come in, and that's what they call substitution reaction. So as you can see, some examples that are here, that chlorine is coming to add to that methane, and that's why we have CH4 plus Cl2. So what later happened here? Instead of the 4H, it reduced to 3. And that's why we have CH3. Then out of the 2Cl, 1Cl was added to it. The other Cl had to join the H that left here to form HCl. So the formation here is called chloromethane. That means the methane has chlorine in it. And take note of the catalyst, ultraviolet. Now we can still proceed with this same chloromethane by bringing in another element again, another chlorine, which means if another chlorine is coming in, another H will be removed. Don't forget, Cl was just added, just like a visitor coming to a place where they only have 4 chairs, and the 4 chairs are there are 4 persons sitting on it already. But immediately these visitors came, so one of the 4 hydrogen, that means the owner of the house, had to stand up for chlorine to come in, which is the visitor. Now another visitor coming in, it means another H will have to leave. That means the owner of the house, another person, maybe the wife now, the first one may be the husband, so second one the wife now. It means another Cl will be added to this, which means a new visitor, making it 2Cl or Cl2. So out of the CH3, H1 will leave, and that's why it will remain CH2. So that one that left will join with the second Cl that is left here to form HCl. So the name of this one is called dichloromethane. That means 2 chlorine now. That means 2 visitors. The first one was only 1 Cl, now is now 2 Cl and 2 H are left. Now we can still proceed again. That means another visitor, which is chlorine, coming to join the remaining ones here. So it means out of the 2 owners of the house, one will be going out again for Cl to come in. The Cl becomes 3, Cl3. So the H here will now remain 1, and that's CHCl3. So the 1 H that is leaving here will join the second Cl that is left here, and that makes it HCl. So the name of this one here is now trichloromethane. That means the chlorine is now 3, the visitors. And another name for trichloromethane is chloroform, so which they use for anesthesia. Maybe they want to carry out surgical operation, so they can use trichloromethane. Now this same trichloromethane, we are adding another chlorine again, meaning a new visitor is coming in, which means the remaining owner of the house, H, will leave for chlorine to come in, which we call substitution. So meaning that there will be no H again, while the Cl will become 4, and that's why we have CCl4. Though take note here that 4 is what will be here, so CCl4. Now the H, so that was removed here, we join with the second Cl that is left, and that's HCl. So the name of this CCl4 is called tetrachloromethane. tetrachloromethane. So this one can be used as an organic solvent. So that is for the chemical properties of alkanes. Now we are moving to, okay, before we move to that of alkanes, the other letter which is C, from S and C that was mentioned earlier, so is now combustion. So it means methane can undergo combustion. When we say combustion, that's addition of oxygen. Remember, oxygen represents air to burn, so it means it's going to use the oxygen to burn this. So in this combustion reaction, always take note that water and carbon dioxide will always be the product of combustion of any of the hydrocarbons. If you move to alkanes, the same thing, the combustion of ethane. If you add oxygen, you will always see CO2 and water. If you come to alkanol or alkyne first, so look at the ethane here, C2H2. So if you also pass it through combustion, so it will still give you CO2 and H2O. And also ethanol, the same thing still happens to it, even though this one is not hydrocarbon but is an organic compound. Its own combustion will also give water and CO2. So generally we have seen that their combustion will give water and CO2. But the difference we now have between the four of them is that for this alkane, the kind of flame you will see, they call it pale blue. The color will be blue, pale blue, and then it will be non-luminous. That luminosity is talking about brightness. So it means the light, the fire will not be that bright because the color is blue, and blue is somehow dull compared to red, orange. So that's why we call it non-luminous. It will give you a pale blue, non-luminous flame, which is the best flame that will help. That means it will be without smoke, no soot, no carbon. So it means there is a good combustion. So that is for alkane. Now we move to alkenes, the chemical properties of alkenes. So in this case, there are some mnemonics that are here, just the way we used cane, school visit for alkane. So for alkane, the mnemonics we'll be using here is captain. You know, from alkane, one of the example of alkane is 18. So meaning that 18, join the 10 with the cap. So you say captain, just like captain. So captain. So how are we going to make use of this captain? So I'm coming back to that. Then along the line, we also talk about I class. So represents the HCl. Then school, high class, like someone that is in higher level, higher class. So that's in school, high class and school. Then you can use HOBR as or upbringing. Upbringing, that means there should be a particular upbringing that will help when the person gets to high class. So you have to add that upbringing, that means the new character, new traits. So you have to put it to use in high class. Then we also make use of this mnemonic proclaim. Proclaim, like we'll be using the word mark when we get to Markonikov. So mark, so that means there is a gospel according to Saint Mark, so that was proclaiming the gospel. So we say proclaim, mark, gospel. So we are going to use these three different mnemonics. So let's start with the captain. So for the letter C, AP. C means combustion. I've explained that earlier, that the combustion means it's adding to oxygen, where the oxygen represents air burning the ethane. So once it burns the ethane, we are going to have CO2 and water. But this one will be smoky. Remember, for alkanes, it's not smoky. It was given pale blue, which is a perfect production of heat. Pale blue, and that one was non-luminous. It was not bright. But this one is now luminous. It's luminous. It's giving bright color. The bright color means the orange color or the yellow color that we always see. So when we see that, it means that is not the best burning. So the smoky, it means it will be full of smoke. Why? Because there is high carbon. Carbon representing the charcoal, so too much carbon in it. So that's why it's smoky. So that's for the letter C of the captain. Then letter A, that's addition reaction. So in this addition reaction, there are several addition reactions for alkene, and that's why alkene and alkyne, they have several reactions compared to that of alkane. So, and the reason is because of the unsaturated, they are unsaturated. So those unsaturated compounds, they easily do more reaction. They have double bond, triple bond, so meaning that they can bring in as many elements or compounds as possible. So they have several reactions. So let's quickly go through the addition reactions. So for the addition reactions, like I said, you can use adding or bringing. That means the way the person was brought up. So adding it to the lifestyle in high class or school. So the first letter here is hydrogen, H from the high class. We are picking the letter H from HCI class. So it means we can add the alkene. The alkene here is 18. So 18 is our alkene. We can add hydrogen to 18. So if you add hydrogen to 18, the 18 will return back to 18. So from alkene going back to alkene. So meaning C2H4 will become C2H6. So then the next one is now chlorine. So for chlorine, which is still from HCl here, so the same thing applies to this. If you're adding 2 chlorine, so 18, the Cl2 will cover up the space. Let me draw open chain structure so that you can get what I'm talking about. You know, 18 is actually C double bond another C, where H4 will be 1, 2, 3, 4, because around every carbon it must not pass 4 bonds. 1, 2, 3, 4. The same thing here, 1, 2, 3, 4. So meaning this was the initial arrangement of 18. So but now they said new hydrogen is coming in. So and that's why we say 18 plus H2. So if 2 hydrogen are coming in, which means one bond here will break. It will not be double again. So it will now stay here. So turning this one to 3H, then this one to another H will stay here. So then you will now have 1, 2, 3 with 1 here. Now it's no longer double because one bond has broken. So it will be complete 4, and the H will now be 6, and that's what we call 18. So meaning that since the double has changed to single bond, so it becomes alkane. So that's how to get that. So the same thing applies to chlorine. If it's chlorine, I'm also adding Cl2. It means instead of the H that is here, is Cl that will be here. The same thing here is Cl that will be here. So we call it chloroethane. So just that the chlorine, anywhere you like to put it, if you put it here, it will be at number 1 carbon, and at number 2 carbon we have chlorine. So we can say 1, 2 dichloroethane. That means dichloro means chlorine 1, chlorine 2, dichloro, and eth means because there are 2 carbons here, so dichloroethane. Now another thing we can add is HCl. So it means we can decide to put only H on the left here and Cl on the right here. So if we do it in that way, it means we will have only 1 chlorine. So it means we just say chloroethane, and that is for C2, that's for the C2H5Cl. So let me try to make this neater so that we can be seeing. So from here now, remember these ones we were just adding them. So it means if I'm bringing in HCl, 1 H will stay here, then 1 Cl will stay here. So that's chloroethane. 2 carbons they represent eth. Now there is now still following this HCl here. Now from the HCl we have said H separately, Cl separately, then HCl joined together. So we use it from this mnemonic. So where I'm now going is that we have been using 18 as our case study. So but in the case of what we call Markovnikov's rule, Markovnikov's rule said instead of using the 18C2H4 that we can try propane, which is C3H6. So if we use C3H6, these are the C3 here. So for the H6, so that one we actually have double bond since it was propane. But by the time you add your chlorine to it, or HCl, so by the time you add HCl to it, it means it will now become chloropropane, and that's what we call Markovnikov's rule. So let me still use the same structure that was drawn earlier. So this is the structure here. It means instead of these 2 carbons, okay, I need to erase all of this. So instead of using 2 carbons here, so we make use of 3 carbons. So that means 1, 2, 3. So for propane, double bonds will be here only in one place. The others can be single bonds. So here there should be 2 bonds, 1, 2, 3. Then the fourth one here, 1, 2, 3, and 4 here. Then 1, 2, 3 here already. Then you can put the fourth one here. So that one now represents propane. So okay, that's this is the propane, just 3 carbons. So this propane now, it means if I want to follow Markovnikov rule, so it said the way we added HCl to 18, if it is to propane we are adding it, what will happen? We are going to break 1 bond here, then extra H will come here, then the Cl can bring it down here. So that's propane. So that's chloropropane, and the chloro is at number 2. So that's 2. You can say 2 because this is 1, 2, 3. So you can say 2 chloropropane. So that is Markovnikov's rule. So before we move to HOBr, let's come back to our mnemonics that we have been using. So it means we said we can use HCl as addition. So adding or bringing high class school. So we add H, we add Cl, we add HCl, then we follow Markovnikov's rule. So from the Markovnikov rule, that was where I used this proclaim. That means we are adding chlorine, hydrogen chloride to propane. So proclaim, adding hydrogen chloride to propane. So then the rule is called Markovnikov. So Markovnikov's rule. So we have used those ones. Now we are still continuing with HOBr and then school. So it means let's now add HOBr. HOBr is called bromine water, or HOCl, chlorine water, or hypochloric acid. So why this one is hypobromic, this one hypochloric acid. So when we add HOCl to the same ethane we are dealing with, what will happen? First, take only OH and put it beside half of this C2H4. Half of C2H4 is 1 of C out of the 2, 2 of H out of the 4, that's CH2. The remaining one half will be on the right, CH2 on the right, CH2 on the left. So pick OH here, put it on the left, pick Cl here, put it on the right. That's if you are using Cl, but if you are using Br, you put Br here. So though here Br is it written, that's if you are using Br, but if it's Cl, you put it here. So how do we now name this? You know, this OH here, if you want to write the structure, you can just say the C, the first one and the second one, they are here. The H, the 2H will be up and down, then the OH will be on the left hand side there, while the Br will be on the right. So because of the OH here, that's an alkanol, meaning that the 2 carbons here makes it ethanol. So you can say bromoethanol. So that's the product. Then the next thing, still following our mnemonics, so I don't want us to walk outside the use of our mnemonics, so that it will help us to remember whenever we are going through this video. So back to the high class, you know, we said add or bringing of high class and then school. So we've said H is the hydrogen, Cl, chlorine, HCl, we add it to it. Then the Markovnikov's rule, where we use the propane. But now okay, joining of the HOBr represents upbringing. So we have also used bromine water. So that's HOBr. Now we are moving to school, SKOO. So what does SKOO? What does it stand for? The S, we use it for H2SO4. It means we can also add H2SO4 to what? Ethene. So when we add H2SO4 to ethene, what will it give us? Just like when we were preparing ethene earlier, we said we need ethanol. This is ethanol, C2H5OH. That if we should add H2SO4 to ethanol, so we will have ethyl hydrogen sulfate, whereby one H will be removed from this hydrogen sulfate. So that's ethyl hydrogen sulfate. That one H that is removed, you join it with the OH that is here, turn it to water. That was for preparation of ethene. So that's the first step. And then when we decompose ethyl hydrogen sulfate, we say it will give us ethene, which is this. So the reverse now is that from that ethene, now add H2SO4. So you also get what? Ethyl hydrogen sulfate, only ethyl hydrogen sulfate. If you now add extra water to it, then it will now break down to ethanol and then H2SO4. Why? Because the OH out of this H2, pick one O, one H, add it to this C2H5, it will give you C2H5OH. Then the remaining H, add it to HSO4 to become H2SO4. So and for this one, how did we get ethyl hydrogen sulfate? So we picked one H from H2SO4, added it to this, it became C2H5. Then the remaining HSO4 will be here. So mean that this one stopped on this line. But we now decided that what if we add water to this one that stopped here? So we will now get ethanol and H2SO4. So that's for the letter S. So following the mnemonic of school, we've taken S remaining K. So the K, we'll be using it for KMNO4. potassium manganate. So if you see this KMnO4, we don't need all of the KMnO4, it's only the O. In short, is one O we need instead of the O4. So that means oxidizing agent. So if we oxidize ethene, so what will it give us? So the secret is that whenever you see C2H4, just break it into half. That means 1C, 1C for the C2, then 2H2H for the H4. Then since we are doing oxidation, one O that is coming here, you put the one O here. So then you now think of one O cannot just stand, we need extra one O. Then from there you can say let's add another HH, and that's H2O. So which means in the oxidation of ethene, so we'll pick the O as the oxidation, then also add H2O, which is water, and that's why you see plus H2O also appearing in it. So another thing, and the name of this compound that is formed is ethane 1,2-diol. Why? Because the carbon there are two, which is eth, and the OH appears both at the first and the second place. That's 1,2-diol. So then, since we are using the mnemonic school, so SK remaining O and O. So the O and O represents oxygen. So we want to add oxygen to our ethene. The second O will now be ozone, adding O3 to our ethene. So when we add oxygen, O2 to our ethene, what will it give us? In short, the oxygen we are adding is just half of this O2. And what is half of O2? That's a single O, meaning that a single O will be joined with the C2H4. When we split C2H4, it means we have CH2 on one side, CH2 on the other side. Why the single O? You know, half of 2 is 1. So the single O will come down. So the name of this is called epoxy ethane. Epoxy. So in terminology, whenever you hear ep or epi, that's something that surrounds, something that covers, or something that is above. So looking at this, it means this earth, two carbons represent earth. So this earth is above oxygen. That's epoxy. Epoxy above oxygen. So epoxy, and because it's two carbon, we now say ethane. And since they are single bond, that's in. So epoxy ethane. So take note, this epoxy ethane is different from dimethyl ether. They are not the same. So because for dimethyl ether, only O will be at the center in this form. So for dimethyl ether, only O will be at the center. Then you have your methyl here. That's CH3 here. You also have CH3 here. So this one is dimethyl ether. It's different from this epoxy. So epoxy ethane is actually a cyclic. You can see it going around. So it's a cyclic compound. So we call it cyclic ether. So why is it ether? Because of the functional group O. So this is cyclic ether, different from this epoxy ethane. So, and this epoxy ethane, which is cyclic ether, we can use it for making ethane 1,2-diol. Ethane, remember it's from the ethane. So we can turn it to OH and another OH. So ethane 1,2-diol. So that's if we want to transform it, and it can give us a liquid detergent soap. So we can use it for the. So finally, ozone. Ozone is another thing we can also add to our ethane. So ozone is O3. So our ethane, we'll split it into two again. Ethane. So CH2, CH2. So separated. Then O3 means we'll put it out one by one. So 1, 2, 3. So this is the structure, which means the CH2 separated. We separated into two places, ozone into 3 places, making 5. And that's why we have the shape of a pentagon, 5 sides. So if you now want to name this, we call it ethane ozonide. Why is it ethane ozonide? Because CH2, CH2 in 2 places, they are ethane. So they are actually ethane. So and then ozone, O3 is ozone. So it means ethane and ozone, ethane ozonide. So this looks viscous. That means thick liquid, and it's explosive. It can explode because of ozone. More oxygen will cause explosion easily. So then another thing from our mnemonic, which we have said earlier, was cap. We say captain. So C is combustion, A is addition, then the P is polymerization. So it means we want to look at the polymerization of ethane. When you hear polymerization, that's addition of monomers to get to produce a polymer, which means if I take ethane and add it with another ethane continuously, I will later get polyethane. And polyethane from the word polyethylene bag. So that's many ethane. They can also call it vinyl chloride. Polyethylene if you add chlorine, sorry, so it's when you add chlorine that we call it vinyl chloride. So but as when you have a many ethene, you call it polyethene, but if there's chlorine, you say chloroethene. So but here chlorine is not added, so it's just polyethene or polyethene. So addition of many ethene is what we call polyethene. So that is for the alkenes. Now we are moving to alkynes. So the chemical properties of alkynes. So there's also a mnemonic that we can use to remember that. So what are the mnemonics we can use here? So let me first erase the ones we have used here so that we can see what we are working on. So from these alkynes, so the chemical properties of alkyne, you can use this pure camp. Pure camp. Now, what is the meaning of this pure camp? Just use the logic, and that reminds me from this alkene. Another thing you can remember when you say alkene, the in, just like a tin, the in a tin, someone that is thin is slim. So what brought about the slim stature? So maybe the person from this mnemonic adds or bring in high class school. So let's say someone that went to university, so representing it as high class school. So it means maybe there was no food, the person was just trying to manage, and then that make the person thin. So in alkene, you remember a thin, someone that is thin in high class school. So then in alkyne, if you want to remember that of alkyne, so that ein from ethyne. So use that time to remember tank. So means that someone that is thanking God need to be pure. So pure. When a person is in the camp, that means the camp of the people of God need to be pure. So pure camp. Use it to remember a time. So pure camp. Then we are coming back to this one that says cocklam, then sin. So cocklam, so sin. So we are still going to just like someone that they put handcuff in the person's hand. That's cock for the handcuff. Then clam from claim. Then the person is now claiming that he did not do what he was accused of. So cocklam, handcuff, claiming right. So due to the purity that the person is known for. So let's now take this pure camp, using it to remember the mnemonics for alkyne. So the pure camp, the pure, what does pure represent? The pure means pure oxygen. When you take pure oxygen and you add it to your ethyne, this is the ethyne. That oxygen with the ethyne, we call it oxyethyne. And since ethyne means acetylene, so it means oxyethyne will become oxyacetylene, which is a flame that was very hot. So the ethyne added to oxygen made it hotter. So if it's ordinary oxygen, it will be hot, but oxyethyne will be hotter. That's what they use for welding or cutting metals. So just like someone that is very pure, a child of God, will be able to penetrate, will be able to do a lot of great things. So that's for pure. Now back to pure camp. The letter C is now combustion. So I've said combustion means you are adding oxygen to your hydrocarbons. So and we always get CO2 and water. Then A means addition. So in addition reaction, so it means we are adding some elements to our ethyne, so which is exactly like that of alkene. So it's exactly like alkene, meaning that the way we added H to alkene, we will also be adding H to ethyne. So this time from ethyne, it will now change to ethene. If you still add it, then it will now change to ethane. Remember, ethene change to ethane, but this one, ethyne, will change to ethene. And again, from ethene, it can now still change to ethane. So meaning this ethyne now, that's C, it will have triple bond, 1, 2, 3. So this is ethyne, having H in front here and H at the back. This is ethyne. So in this ethyne, they say if we add hydrogen, so hydrogen is H2. What will happen out of these 3 bonds? One bond will break. And if one bond has broken, it means one H will come here. So to make this bond 1, 2, 3, 4. Then this one that is now 1, 2, 3, you need to add extra H. So which will make it complete 1, 2, 3, 4. So mean that from ethyne, which was C2H2, it has become C2H4, which is ethene. So ethene, and that's what you have there. Now if you add another hydrogen again, H2, it means you have to break this last bond and then add extra H. So this one too, you add extra H, so it will now become C2H6, and that's ethane. So, and that's just the secret behind it. So the same thing, if we do that for chlorine, if you break one bond, so Cl will be added to this. Let me erase this. So if you add chlorine, the same thing applies to it. It means Cl will be here, and then on this other side, let me just shade it. So on this other side, Cl will also be there. So, and that will be dichloro. So we call it dichloroethene because it will still be double bond. But by the time you remove the two bonds, it means another chlorine will be coming in. So Cl will come in here, another Cl will come in. The chlorine will now be 4, which we call tetra. That means 4 chloro. So the tetra means at number 1 carbon there is chlorine. That same number 1 there is chlorine. That's 1 1. Then at number 2 carbon there is chlorine, number 2 carbon. So you can say 1 1 2 2 tetrachloroethane. So that is for the way the operation. But if it is HCl that is now coming, instead of the Cl you see here, so it's just 1 Cl here and 1 H. So it's just for you to count the number of chlorine that will be there. So just follow the principle that was used in alkene, so that we will not waste time on all of this. So by the time you follow the principle of alkene, you also get that of alkyne. So now let's proceed. So we have seen that in addition, we add hydrogen just as we added to that of alkene, and adding H2, just do addition here from H2 to become H4, which is ethane. Then adding H2 again from H4 to become H6, which is ethane. So then if it is chlorine that you are adding, so it means this C2H2, the chlorine, since chlorine and H, they are not the same, so the Cl2 will just stay beside. If you are adding another chlorine again, so since chlorine and chlorine they look alike, the chlorine will now become 4. So that's why you see 2 on the right, 2 on the left. So, and the name, so if you have 2 chlorine, we call it dichloro. Then when we come down here, so now that the chlorine, they are now 4. That's why you see that the 2 chlorine, they are beside number 1 carbon. Then the second 2 chlorine, they are the number 2 carbon. So it means the 2 chlorine, they are here 1 1. Then they are also here 2 2. So and 4 of them, we call them tetra of the chlorine. So 1 1 2 2 tetrachloroethane. And take note, always remember your catalyst. Like here now, there is a warning that absence of catalyst, if you did not put your catalyst, will cause a violent explosion, and there will be a formation of carbon like ash color. I mean, like ash. Talking about the just like charcoal. So there will be ash when something explodes. The acid HCl. So it's like joining ethane with chlorine. You are expecting acid. So that's why there will be a kind of violent explosion, assuming there is no catalyst. And that's why the catalyst we use here is a metallic halide. A metal, a metal and chlorine, or metal and fluorine, just metallic halide. So then at the beginning here, his own is nickel. We use nickel as our catalyst. So that is for the Cl. The same thing applies to HCl. Just follow the alkene. All those things we added in alkene is what we are still adding here. So if you are adding HCl, so H resemble the H2 here, making this one become H3. Then the Cl here will join with this, and the name we give it is chloroethene. Chloroethene. It means it's no longer ethane. Turn to ethene. So if you add another HCl, so H will join with the 3 to become 4. Cl will join with Cl to become 2. So it means here now, it means the 2 chlorine. So we can put it at the beginning of the first carbon. You know, there are C2 here. So if you put both chlorine at the beginning, that will be 1 1 dichloroethane. So it means it ended up as ethane. So the same thing we added to alkene is what we are still adding to alkyne. So it's only this H2O we did not add to alkene. So we are adding it to alkyne. So water is the special thing. So let's just say from alkyne, like I said, someone that is thanking God. So it means he's making use of water, so which is H2O. So this water, which is H2O now, if I add it to ethane, so adding it to ethane, it will give us ethanol. So meaning that one H here will join with the H2, it will become H3. Then there will be OH left beside it. So that's ethanol. So if let's looking at the structure here, when I try to bring out the open chain structure, we will say C double bond of C, then triple bond since it's ethyne, and then H will be at the back and also H in front here. So that is for ethyne. So this ethyne, if I should add H2O, it means the H that was 2, here, we say it will become 3. So the H that was 2 here, we say it will become 3. Now that is becoming 3, it means one H will stay here. So if one H is staying here, it means one bond will be broken. And if one bond is broken, it becomes ethene. But we now said ethanol, and that's why OH, extra OH will be here. So and that's C2H123, then the OH. So that's ethanol. Now this same ethanol can also become ethanol. How will it become ethanol? Though it's still the same formula, just for you to spread. So all you need to do is to spread this one. So that means the CH3, you just bring the H that is here. This H, just bring it here. So once the H is here, that's methyl. Then this OH and the C represents the functional group of alkanal. So that's ethanol now. So ethanol. So it means from ethanol to ethanol. Now the next thing we'll be looking at after adding water is KMNO4. So just follow the mnemonics. That means those things we added to alkenes. So we are still adding it to alkyne. So we are adding KMNO4, and take note, the KMNO4 we are using here is actually only the O, and that O represents the oxidizing agent. So the O represents the oxidizing agent. So when we look at the oxidizing agent, so when we take oxidizing agent, we are only going to use the O. So the O is just what we are going to use. So it means oxidation of ethyne. This is ethyne, C2H2. So the oxidation means we are picking only the O. But this time we are using all the 4 O. You know, earlier we said only a single O, but here we are using 4 of the O. So using 4 of the O, it means the ethyne C2H2 plus 4 of the O will make, just like splitting this, let's split C2H2. It means one C will be up, one C will be down. Then this 2H, one H will be up, one H will be down. Then the 4O we are using will be 2 up, 2 down. So, and since we have 2 carbons, that's eth, so we say ethane. And since they are carboxylic, 2 of the carboxylic, so we say dihoic acid. So ethane dihoic acid will be formed. Then after the KMNO4, we can also make use of metallic derivatives for our alkanal, for our alkyne. So metallic derivatives for our alkyne. So in what way can we use metallic derivatives for alkyne? Now this metallic derivative, remember we are still following the mnemonics that talked about pure camp. So the M now is the metallic derivatives. So you notice that in alkene, metallic derivatives was not used, and that's what differentiates alkene from alkyne. So in alkyne there is metallic derivatives, but in alkene there is no metallic derivatives. So you can just say this is M, there is metallic derivatives in alkyne, so just like mine, but there is no metallic derivatives in alkene, me. Then that M, you can turn it upside down. We use water also again in alkyne. So let's now go and make use of the metallic derivatives that we said we'll be using for alkyne. So how does this metallic derivative, how does it operate? So I call it metallic derivatives of ethyne, and that is metal carbide. So if you want to remember this, I've given a mnemonic from the beginning, which is about sin. So we say Cochran, sin, thank. That means from alkyne, like ethyne. No, I said ethyne. Just remember ethyne with thank. Someone that is thanking God. So we now say this person that is thanking God, we see the person as a pure person, holy person. So if this pure person that is thanking God now committed sin, that's from sin. This sin means silver nitrates, or they try to put handcuff on the person's hand, from the core clamp handcuff, and the person is claiming that no, that it was just a wrong this thing, like trying to say what is not right concerning him. So it means working on a time, you use the word thank, someone that is thanking God, and we say the person is pure. So if there is now sin coming in, sin, so the representation of the sin, as I said, silver nitrate, we'll be making use of silver nitrate. Then copper, the clam, you use the Cu to represent maybe cup, handcuff. So they put handcuff in the person's hand because of the sin. So and they try to claim that no, that what they did is wrong. So let's go and check the sin for silver nitrate. Then this core claim for copper chloride. So copper chloride. So these are the things we'll be using for our metallic derivative. So I'll start with the sin, which is the silver nitrate. So meaning that ethyne, when you add silver nitrate to ethyne, it will give you a metallic carbide. So that means that person that we said sin was added to the person's life, sins to a time, someone that is thanking God, sin added to the person. So it means there will be a chloride or a carbide, so we call, or let's say metallic carbide. So that metallic carbide is one I called MC, metallic carbide. Now turn it to mic. That means there will be a kind of microphone that will be announcing it that the person committed sin, the person that was thanking God a time. So microphone, so use it to remember. So that's for the metallic carbide, silver carbide. So and once you have brought out your silver carbide, the H will join with the NO3, HNO3. So telling us that we can only get a metallic carbide, or yes, as a metallic or a metallic carbide or derivatives. So only when we use ethyne with silver nitrate. But if we use silver nitrate with ethyne, it won't give us metallic derivatives. So another thing that will produce our metallic derivatives is now from that someone that they put handcuff in his hand and he claims that he's innocent. So that handcuff, that's the cup, there is claiming that's the chlorine, so copper chloride. So they claim, Cl, the Am is ammonia, claim. So it means ammonia and copper chloride, when you add it to the ethyne, someone that is thinking God, it means there will also be a metallic derivatives, which I call the metallic carbide, copper carbide. So these metallic derivatives is found when we add copper chloride and ammonia to ethyne, or we add silver nitrate to ethyne, we get these metallic derivatives, copper carbide, silver carbide, but we never get it when we add them to ethyne. So these are the differences we can bring out when we are differentiating between alkane and alkyne. Then finally, for that of alkyne, polymerization. Remember, we are dealing with camp, C-A-M-P. The P is the polymerization. So which means when we take ethyne, we add ethyne with ethyne with ethyne, so it can give us a large structure. So let's watch out. This is our ethyne, C2H2. So if you take 3 of it, then it will turn to benzene. And benzene is having 6 carbon, 6 hydrogen. So we have polymerized ethyne to benzene. So that's polymerization. So before we move to ethanol, which is the last one, how do we test for unsaturation? Because we have looked at alkane, which is saturated, alkane and alkyne, which are unsaturated. How will you know that this one is saturated, that one is unsaturated? So just get a bromine water from the Br, reddish brown, R and B, reddish brown, that's the color. Or you get purple KMNO4. So immediately you add any unsaturated compounds, maybe alkene or alkyne, they will decolorize that purple. So it will decolorize it. So but if it is saturated, that's alkane, it will not decolorize. So let's now look at the last one, which is alkanol. So for alkanols, the chemical properties of alkanos, we can use this mnemonic code, 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 then PK, just like penalty kick, code PK. So and since we are dealing with alkanol, just like ethanol, ethanol is like alcohol. So it means if you remember when I was talking about laboratory preparation of ethanol, so the either the lab preparation or the uses. So that I said the person will use speed meter to escape. Someone that maybe went through that went to school with a second class upper, and then they was trying to make it, but because of the VC, so that held the person down. So then we said there should be a kind of speed meter to escape. So here also there will be a code to come out of this alkanos, a code. So code, you can also liken it to PK, penalty kick. That means there's a code of playing penalty kick if you will score. So code PK. So let's take them one after the other. Letter C represents combustion, which I said is for every all these organic compounds we have been talking about. So it means combustion means we are adding oxygen to our ethanol, which will give us water and CO2. So remaining letter O. So, and also take note of the color. They said this one will give us a pale blue flame. Remember, when there is a pale blue flame, it means it will be non-luminous, it will not be bright, and that's the best burning. And how will you remember? Remember, alkanol is like alcohol, just like methylated spirit, it will burn well. So it means it will give us pale blue. So let's move to letter O. So O represents oxidation. It means we can do oxidation of ethanol. So oxidation of ethanol means we are picking only letter O. That's oxidation of ethanol. So how will you remember this? Just say nonanoic. The no is the ethanol. The na is the ethanol. Meaning that when we put O, when we oxidize ethanol, it returns to ethanol. And how will you remember? Since ethanol is CH3CHO. So if you go and check one of my videos, so you will see how to derive all this ethanol and the likes. So it means this C2H5OH, how did it change to a CH3CHO? It's very easy. So it's just to say from this C2H5OH, just pick one O. So the one O you are picking, or in other way around, you can say split C into two. That means half. So you put one C here, the other C here. Then the H, you bring this H down here, and the O, you bring this O down to this place. So that will be CHO. While the second C, you leave it here. Then out of this 5H, you put 3H here. The remaining 2H, join it with the O here, and that's H2O. So we name this one ethanol. So it means from ethanol, we have produced ethanol. Now this ethanol, we can now also still change it to ethanoic. So like I said, if you want to remember, I just say nonanoic. Nonanoic. The no is the ethanol. Then the na is the ethanol. Now remaining the noic, ethanoic. So how do we get ethanoic? So we don't need the H2O that is on the other side. We only need the ethanol. So when we take the ethanol, we are also going to oxidize it. That means just bring down the ethanol, then still oxidize. So not adding water, only O. So what will happen here is that the CH3 here, you just bring this O to the center. So bring the O to the center, then the second O here, join it with it. So it means we now have double O coming to the center of C and H. So you now have O and O at the center of C and H. That's CH3, COOH. So this O and this O will give us ethanoic. So that's for the oxidation. Then another letter we are also using because we are making use of our mnemonic. So from the mnemonic we have code CO. D now is the next thing. We have seen oxidation. So then the letter D. D means dehydration. It means we can dehydrate ethanol. So when you say dehydration of ethanol, that means remove water from ethanol. And the only thing, one of the things that can remove water, that means a dehydrating agent, is H2SO4. So it means H2SO4 will help to remove water from ethanol, but it's a two-way process. The first process is that when you bring your ethanol with H2SO4, it will first give us ethyl hydrogen sulfate. That means out of this H2, one H will be brought out. So if one H is brought out, then it will remain C2H5, then HSO4. The one H that is brought out, we join it with the OH that is here to give us H2O. So you now pick the ethyl hydrogen sulfate, leaving the water, and then decompose it. You heat it. When you heat it, your C2H4 will come out of it. This is C2H4. Then one H will join with this H again and give us H2SO4. So it means if you now want to summarize everything, it means this ethyl hydrogen sulfate that is here. So if you also try to add ethanol, it means another compound will be formed. So when we decompose ethyl hydrosulfate, it gave us ethene and H2SO4. But if you now use ethanol, extra ethanol with what we have got, we started with ethanol. If you want to end it with ethanol again, that's ethyl hydrosulfate, then it will give you another compound which I call ethoxyethane. That's ether. Ether, this is ethyl on the left, ethyl on the right. So it means ether or diethyl. So diethyl ether. So or you say ethoxyethane. So ethoxyethane. So ethyl on the left and on the right. So ethoxyethane. So with H2SO4. Now, from these products, we can also proceed to, okay, we have seen that of the, let's come back to the code. Okay, so that's for the D for dehydration. Then letter E now is what we call esterification. So esterification. So in esterification reaction, it means we can use our ethanol, which is C2H5OH, add it with ethanoic, and that will give us ester and water. So there's a video for that also, this esterification, that's under alkanoic acid. So that one you get, and there will be a catalyst H2SO4. So that's esterification. So from the code, the remaining pK, we say code and pK. So the letter P, that's phosphorus 5 chloride. So you can also still take your ethanol, add it with phosphorus 5 chloride. So what will happen is that the Cl will be shared into 3 portions. So for the ethyl, C2H5, Cl will join with the C2H5 to give us chloroethene. Then the second Cl will join with the P, and O will be brought in. That means you bring this O to the P, and then 3 Cl will be taken here. That's POCl3. Remember, 1 Cl has joined with this to give us chloroethene. Then we now said this O will come and join this Cl again as POCl3. Then the remaining one will be H that is here, and the last H and the last Cl. Remember, there are 5 Cl, so we join and give us HCl. So that is for the P. The remaining K again. So for the K, it means we can also take the ethanol and add it with, sorry, let me okay, the K is potassium. It means you can also add ethanol with potassium or sodium. So if you add it with potassium or sodium, it means the H that is here will be leaving. So why sodium will come in? So if sodium comes in, so it will give us sodium ethoxide. That means this is sodium and this is ether. Remember, ether has ethyl on the left, ethyl on the right. But instead of ethyl on the right, we are putting sodium on the right. So we call it sodium eth, 2 carbons, ethoxide. So while the hydrogen that is leaving will come to this right hand side. And if you want to add cold water again, extra cold water to that sodium ethoxide, it means the sodium will pick the water and turn to sodium hydroxide, while the ethyl C2H5 will be taking the the C2H5 that is remaining here. So it will come with the O. Remember, we said if we had cold water, the Na will pick OH from the H2O. The remaining H will stay with the C2H5O. So it will replace the Na and come back to ethanol. So that is for the K. So we have been able to see that of the alkanol using code pK. So let's see, is there any other one that is untouched? Okay, so finally, under this topic, remember alkanol, there are different classes and types of alkanol. So when you hear class, there is a primary class, secondary class, tertiary. So it means we have primary alkanol. A primary alkanol has just one alkyl attached to the carbon that carries hydroxyl. This carbon is one in front of hydroxyl. So you count the number of alkyl, that means CH3 or ethyl and so on, that is very close to it. So we have only one here. So that is a primary alkanol. And the name of this one is ethanol because the carbon here, there are 2. Then secondary ethanol. So the alkyl will be 2, 1 and 2 attached, or they are very close to the carbon that is in front of this hydroxyl. So, and this one now is a secondary because they have 2 alkyl, which I circled. If you want to name it, you start from this upper part to form a longest chain, 1, 2, 3. It means at number 2 there is O. and that's why you get 2-O. And because the carbon are 3, so we say propan 2-O. Then the tertiary, if it's now tertiary, you now have methyl in 3 places. So you have methyl in 3 places for the tertiary. So now from this tertiary, we will say the methyl 1, methyl 2, and methyl 3. So it means alkyl in 3 places. So it means you will count 1, 2, 3. That's for the longest. Why there will be a branch at this number 2. So that branch is methyl. So you say 2 methyl because there are 3 carbons here. So you say propanol, 2 methyl propanol. So that's for the classes. Then for the types of alkanol, we now have monohydric, dihydric, and trihydric. So monohydric, it has 1 OH, dihydric 2 OH, trihydric 3 OH. From there, hydroxyl. So if it's having 1 OH, that's monohydric. An example of it is methanol. If it's having 2 OH, that's dihydric. Example is ethane 1,2-diol, because the carbon here they are 1, 2. So eth 1, 2. So ethane 1, 2. The OH is in 2 places, diol. Then propan 1, 2, 3 triol. That means 1, 2, 3. So that's 1, 2, 3. The OH appears in 3 places and they are prop. So that's propan 1, 2, 3 triol. So thanks for listening.